welcome to my YouTube channel. So here today we are going to be looking at Unit 5, which is storage. So under this unit, we are going to be looking at 80 questions. So the first question says, what is the main function of memory in the computer? So memory, let's look at, when we are looking at memory, we are mostly talking about main memory. And main memory, we are mostly looking at RAM, which is random access memory. So this random access memory stores data temporarily. So it stores data and instructions temporarily. So under this type of memory, the storage is that it executes running operations. So like for example, if I do this, you may see these. So these are running in the background. So these things are temporary. If my device switches off, it will not be able to start where it was. So that is basically what RAM is.
I have to move it, right?
When we have storage on the other hand, storage permanently stores data. So under storage, we have, it is put in a permanent place. Like for example, if you have your space, which is, let's say, 256 GB, that's your device, whatever space will be used, it will be permanently stored there. Or if you download a book, it will be permanently stored there. So when we are looking at which of the following best describes storage, so storage has to do with the permanent data retention. When we look at our question number 3, memory is typically, so remember memory, we are mostly looking at our RAM. So memory is volatile, meaning to say it loses its content every time power is off. When we look at our number 4, we have a storage medium is also known as. So as long as you are looking at a storage medium, that is an example of. So our answer there is secondary storage, which is our B. So as long as we are looking at a storage medium, the one that stores data permanently, the example that we might have is a hard disk drive or a solid state drive. So these store data permanently like that. So this could be the device's space and all that. Our number 5, we have which of the following is an example of a storage hardware. So a storage hardware that we have is, we can have storage hardware, we can have SDD, which is the solid state drive, SSD, solid state drive. So this is a type of space that permanently stores data. So this could be somewhere, which is the device space. It could be 256 GB, it could be 64 GB, it could be 32 GB, you name it. It could be 1 TB sometimes. So that is an example of secondary storage, or rather storage hardware. So this is a physical space where you put documents. So this is an example of SSD hard drive. So inside, this is how it looks, like that. So this is basically what stores space. So as you can see here, we have 512 GB. So this is the actual space that is used to store documents, movies, you name it. Our number 6, cloud storage stores data. This one, cloud storage, stores data on the internet servers. So it stores data on the internet servers. So that's why it is called cloud storage, like that. So you can access this data anywhere using any device. Like for example, if you have your phone, or let's say your laptop, which is 128 GB space, then you have things there. Now you decide to leave your laptop. Let's say you are from one town to the other town, which you are going to call town B. You can access the exact information that is in your laptop if you uploaded it on the cloud. So now this uses powerful computers called servers. So these servers are able to store that amount of data, and then you can be able to retrieve it. So as you can see, these are servers. So these are servers. These are very, very supercomputers that are able to store huge chunks or huge amounts of data. So you link your laptop, you send your data to the internet, it is stored through these servers. So these servers store your data, the huge amounts. So they are able to store huge amounts of data. When they store that, then you, let's say you have a laptop, but you just decide to move with your phone. You decide to move with your phone from this town, let's say, to town B. Then what happens is that for you to access the same information that is on your laptop, you can access it anywhere you are using a different device to retrieve certain important information, such as an identification card which you captured, then you send to the cloud, can be retrieved in that manner. If you look at number 7, which device stores data permanently? So the one that stores data permanently is the hard disk. So the hard disk stores data permanently. So these things such as RAM, you saw how RAM works. You look at cache. Cache is used to store information that is frequently accessed. So let's say this is the hard disk. Let's say that this is, or should I say, let's say this is the RAM. Then we have cache here, which is smaller. Then we have the CPU. So let's say the CPU is the boss. So whenever the CPU wants to retrieve certain information, and like going for RAM, which is bigger and information can be difficult to find, you will find that if you access things frequently, it is stored in cache, so that if the CPU wants that information, it can easily get from the cache. So cache is not permanent, so it depends on the information that you use. Then registers are the fastest type of memory which can be used to retrieve information, but they are not permanent information. They change, just as RAM, just as cache. Let's look at our 8. What is the main difference between memory and storage? So the main difference between memory is volatility, meaning to say for memory it is volatile, meaning to say it loses its content when power is cut, and also performance. So basically memory is faster to access while storage is not. An example of memory, we might have RAM, but for storage we might have the space which can be stored in the hard disk drive. So RAM is basically is faster to access. So volatility and performance is the main difference between memory and storage. Number 9 says, which of the following is volatile? So volatile, we have this one, RAM. So this is not volatile, meaning to say its content is not lost whenever the computer is switched on. Examples of RAM is what we call the BIOS, which is the basic input-output system. So this stores instructions such as how to turn the computer on, so that certain information must not be lost. Like for example, the computer always knows how to turn itself on. That is stored in RAM. SSD, we have discussed about it. Hard disk, we have discussed about it. The only difference is that hard disk is made up of a moving part, like a disk that rotates, whilst SSD is not made of moving parts. We are going to dive deeper into that. Our number 10, which stores instructions waiting to be executed. So remember, as long as it is holding instructions waiting to be executed by the CPU, we are going to call that one as memory. Just as I gave you as an example, those background things are using the memory of the computer. Then when we look at our writing, so this is an important term in computer. So remember, when you are writing something, it means to say you are changing certain things. So now that means to say, if you are writing something, just imagine you are writing something. Writing is transferring data to storage. So whatever you write like that, then you transfer it to a storage. That means to say it has been distorted. Like for example, let's imagine you have been sent a word text. There is a word text in the hard drive or maybe a flash drive. Then that one has got words. When you get that information on your PC, then you are so let's say you get it on your PC like that, then you add certain things that were missing, then you put it back to your in your flash. That simply means to say you are writing. So writing is transferring data to the storage. So writing is transferring data to the storage from the CPU. Then when we look at reading simply means to say you are transferring data. Where is it? Reading simply means to say transferring data from storage to memory. So transferring data from storage to memory. Like for example, if you open a text like that, it's written like this. So if the flash has this, when you open that text, you will find that when it opens, it will show you the same text. That means to say it's reading. You're transferring from the storage to the memory, and here we do not make any changes under reading, which makes sense. You read, it means to say you are not changing anything, but when you write, it means to say there are things that you are changing. Number 13, a storage device is used to store and retrieve data. So whatever you use to store data and retrieve it is a storage device. When you look at number 14, access time measures. So just as the name entails, access time, it means to say you're looking at the speed of locating data, how fast you're able to locate data. So from, let's say, you have your A there, how fast you're going to find, let's say if you have data, you're a person, you want that certain data to be retrieved. How fast you're going to find that data is what we call access time. If let's say for example it takes 2 seconds, that means to say that's the access time, the time it will take for you to access certain data. Now a lower access time means better performance, because that means to say you are taking less time. Like in our example, let's say this person takes 1 second. That means to say this computer performs better because it's accessing or locating data very fast. Then when we look at our number 15, we have transfer rate refers to. So this is very simple. Transfer rate has to do with the data transfer speed, how fast the data is being transferred. So let's compare. If you are looking at, let's say, Bluetooth has got a lower transfer rate. You will find that just to enter something that is 7 MB, it will take like forever, as compared to, let's say, when you're looking at applications such as ShareIt, which have got a better transfer rate. You can even transfer a movie as big as 2 GB under 10 minutes. But for Bluetooth, if you take it, if you were to transfer something that is 2 GB, it would take the entire generation of people. Some people will even die. When we look at our number 16, it says which unit measures transfer rate. So in this case, GB has to measure space, the kilobytes per second. It could be kilobyte per second or megabytes. P means per, then second, like that. Hertz measures the clock speed, how fast the computer is executing instructions in a second, or how many instructions are being executed in a second. Inches has to measure the screen size. So the answer there we have chosen kilobytes per second. Fastest access time means, so the fastest access time, if the computer can access data at a very fast rate, then that simply means to say that computer better performs. It performs better, in other words, because you are already getting information at a faster rate. 18, transfer rate is measured in, so it's bytes per second. So it has to do with the space, bytes per second, how much amount of data is being transferred per second. When we look at our 19, we have which operation moves data from RAM to storage. RAM, which is part of the CPU, to the storage. That is what we call writing. Don't forget that. So writing is moving from the RAM or the CPU to storage. The other way around, it is reading. Our number 20, which one moves data from storage to RAM? This one is reading, because you are not making any changes by that time, because you are moving it from a storage device where it is stored, such as a flash. Let's say you have a movie, you open the movie, immediately you open it, will show you the exact contents that are there. Number 21, a byte represents, so a byte is made up of 8 bits. We are looking at this one now. 21 KB is, K is kilo, so it is 10 to the power 3, and 10 to the power 3 is 1000. So kilobyte is made up of 1000 bytes, not bits but bytes. 1000 bytes, like that. 1000 we're here. 1 megabyte. Mega, according to your introduction to chemistry and physics, you will find that mega is 10 to the power of 6, and 10 to the power of 6 is the number of zeros. We will have 6 zeros, which is a million. So 1 million bytes make up what we call a MB. Then when we look at our next one, we have our 24. 1 GB is equal to a giga, has to do with 10 to the power of 9, which is a billion. Billion has those number of zeros. So we have a billion has 9 zeros. So we are going to have, that will be a 9 billion. Then when we look at 1 TB equals to, so remember, a TB is 10 terabytes. That's the meaning, terabyte. Tera is 10 to the power 12, which is a trillion. So it is 1 trillion bytes for number 25. Then when we look at our next one, we have which one is the largest unit. So it is not the largest unit, but the largest unit among these. So if you look at your giga, it's 10 to the power of 6. Your tera is 10 to the power of 12. Then our peta is 10 to the power of 15. Mega is 10 to the power of here it should be 9. Then here it should be 6. So the highest is a petabyte. So we have the peta is 10 to the power 15. So then we have bytes. So this one is the largest according to this list. Zeta comes after. So after the petabyte, there is the exabyte. After the exabyte, then there is the zettabyte, which is, the exabyte is 10 to the power 18. Zettabyte is 10 to the power of 21, not 24. 21, like that. Peta 10 to the power 15, like that. So zeta comes after, so it comes after what we call the exabyte. Yottabyte is now yottabyte is the largest unit. So yotta is 10 to the power of 24. So it is the largest unit listed. Then when we look at our 29, capacity refers to, if you are looking at capacity, it just has to do with the space that you can accommodate. So capacity has to do with the size of storage. For number 30, we have which unit is used for very large data. So for very large data, we are going to have petabytes. Remember, it's 10 to the power 15. Kilo 10 to the power 3. Mega 10 to the power 6. Bytes is just 8 bits. So for very large data, we are going to use peta. HDD stores data using So the hard disk drive uses what we call magnetic particles to store data. So this is the hard disk, which is made up of moving parts. So this rotates like that. So it uses magnetic strips to be able to store data. So this is how it looks in another image. A platter, on the other hand, is a circular disk inside the HDD, which we are going now to look at other terms such as a track. So from our hard drive, the hard drive is made up of a platter, which is this whole thing. Then we have what we call, if it makes a complete circle, we are going to call that complete circle as a track. So that is a track. Then when we look at more like a portion of the track, we are going to call that one as a sector. So as you can see, just from here up to here, this is a sector. It would make sense, especially if you did math. So this is a sector like that. Then from a sector, which is this one, from a sector, we are able to combine these sectors. We have one sector there, we have another sector there, we have another sector there. We are now going to call this as a cluster. A cluster is a combination of sectors like that. So this is how we split the platter. So just as we have said, a platter is a circular disk inside the HDD. Then when we look at, which is the hard disk drive, when we look at our number 33, our number 33 says tracks are circles on a disk. So that complete circle is a track. So we have circles on the disk. Sectors are, we have the divisions of tracks. So if you have the division, we have a track like that. Then the division of a track, we get a portion, that is a sector. When these sectors come together, they will form a cluster. A cluster is a group of sectors. When we look at our next one, we have formatting a disk. So what is formatting? So formatting, many people think of it as just deleting, but in this sense, it is not just physical formatting, but formatting actually organizes disks into tracks and sectors. So that is basically what formatting is. It organizes disks into tracks and sectors like that. Then when we look at our density, we know that from our physics, we know that density is mass over the volume. So the mass, you can think of it as the space, the amount of data in a space. So in this case, then the volume, you shall just have your area. So data is just the bits. Bits is the space or the amount of information or data per area. So that substitutes mass, volume is substituted by area. So that's the density. Higher density means more storage, because that means to say it can accommodate more of the data per unit area. So that means to say for more, if there is more density, that means to say there is more storage. Number 39, read write header. This one is very simple. We have read write head. What it does is that it reads and writes data. We now know what to read is. To read, it simply means to say you are more like sending something to the internal thing, to the internal, which is the CPU, which might be represented by the RAM, from the storage. That is what we call reading. Then writing, it is from the CPU to the storage. Then when we look at our 40 actuator moves, so this is the actuator. So what it does is that it controls where this will read and where it will write like that. So as this is rotating, there should be reading and writing. Remember, reading is moving from the storage to the CPU. Let's say what data is here. So remember, this is made in a magnetic way. So what data is here? That is what the computer will read, like that. But if you want to add more information to the hard disk, you will be writing. So this part is what controls that movement. That is the actuator, like that. So that is basically what the actuator is. So it will move the read and write head. So the read and write head, which is that thing that is on the disk, like that. So it will be able to move that thing that is on the disk so that it can read certain information and write on certain information. When we look at our platters, spin to, so this spins to increase the speed of access time, so that information on the hard disk, remember the hard disk, like that, stores data, so that information can easily be accessed at a very fast rate. That is what we call reading, like that. When we look at our 42, it says that cushion of air prevents. So the cushion of air prevents. So if this is a disk, the platter does not necessarily have to touch that point. So this cushion of air prevents contact damage, so that it can just read. Remember, these are magnetic, so it can easily read without contact. So the cushion of air prevents contact damage as the head is reading and writing certain information. When we look at our 43, external drives connect via what we call the USB, which is the universal serial bus. So the USB is the universal serial bus. So this is what connects external hard drives. So we might have this as our USB, like that. Let's imagine that this is our USB, which looks like that. So that is our USB. It connects to the computer. So it is a cable that connects to the computer, like that. So that is basically what the USB is. Many of you have already seen it. So that thing was an external hard drive. As you can see, this is an external hard drive. It is found outside the computer. It stores materials, among other things. Then HDD is usually, so HDD, since it is made up of moving parts, it is slower. So the options we are looking for is slower, or it is cheaper than SSD, which is SSD is expensive because it is not made of moving parts, meaning to say information is even easily accessible and it has got a faster access time. SSD uses, so if you are asked about SSD, what type of memory it uses, SSD uses flash memory. Then flash memory is non-volatile, meaning to say even if you power cuts or goes, it does not lose its information. That's how come you're watching a movie, when electricity goes, when you put your flash again, you will find the same movie. It is not like if electricity goes, that movie will no longer be in the flash. No. So it is non-volatile, meaning to say information is not lost. SSD has no moving parts, like HDD, the one with platters and all that. Then our 48 USB flash drive is used. So a flash drive is used for portable storage. You can easily get your flash and move with it. 49, memory cards are used in. So memory cards are used mostly in cameras. So not the monitor, not the keyboard, but things that need storage. Like for example, a camera will use a digital camera will use what we call a memory card, so that it can store that information. 50, flash memory can be, so you can erase and rewrite, meaning to say you can delete certain things You can delete certain things but still add. You can reuse it as many as possible. Some things you cannot rewrite, like for example, when you're just looking at a compact disc, the old version, the compact disc, whenever there are just movies there, whenever there are just movies there in the CD, the same movies, you cannot delete them unless you are looking at a compact disc rewritable. So CD compact disc rewritable. For this one, you can be able to rewrite, meaning to say you can add movies. There are those discs. So a flash memory, we know to say you can erase and rewrite, meaning to say you can use it many times and add certain things. Portable devices are, so portable devices, for a device to be portable, it has to be removable. You can easily remove that device. Then our 52 SSD is faster because it has no moving parts. USB means universal serial bus. Then we have memory cards are, so memory cards are examples of flash based. So flash based, we can have SSD, we can have the memory card, we can have the universal serial bus flash drive. All these use the flash based memory. SSD is an example of, so SSD is an example of secondary storage. Primary storage is made up of RAM and ROM. Remember, ROM holds important instructions such as telling the computer how to turn on and off. So primary memory is made of that. Secondary memory, SSD, HDD, like that. When we look at our 56, optic discs are read using, so optic has to do with light. So the one that uses light are laser beams. So if you have a device like that's the one, for example, that reads barcodes, it will be able to emit some form of light, which are in form of a laser. So optic has to do with light. Then when we look at our 57, we have CD stands for compact disc. So we have compact disc. So this one is used, the last letter should be a C. So the compact disc, like that, not the K. Then when we look at our DVD, is mainly used in, so DVD is mainly used in videos. So a long time ago, we used to use DVDs for our video. So the meaning of DVD is digital versatile disc, like that. Then when we look at our next question, 59, Blu-ray has, so Blu-ray has, so basically a Blu-ray was mainly built to increase capacity. A DVD, on the other hand, has got a less capacity as compared to the Blu-ray. Blu-ray might store much data than the DVD. Let's look at our number 60. Cloud storage stores data. We have talked about this, so it is online. Then our 61, cloud computing consists of, we have the front end and back end, which we are going to explain. So the next one, front end, includes the user interface. So front end, like for example, so let's answer these two first. Back end involves servers. So if we look at these servers, this is what we call the back end, where you're storing your information. But for you, that will be the front end, the person with that data or where it's coming from. So we can have the front end. Then for the ones where we have the servers, that's the back end, like that, which makes sense. So the advantage of cloud storage is basically accessible anywhere. So wherever you go, you can easily access cloud storage. You have stored something, let's say you have stored a photo on the cloud. If you want that photo, let's say you left your phone, you are now in you're moving from countries such as Zambia, now you are in countries such as America, so that you can just access that photo using the cloud, so it can be accessed anywhere as long as you upload it. Then when we look at our SaaS, SaaS simply means to say we are looking at software as a service. So this software as a service allows you to be able to access certain applications online. Like for example, when you're looking at the Microsoft, the example that we might have is Microsoft 365. So Microsoft 365. So this allows you to be able to edit Excel. You might be able to edit your documents and all that. So now this, you do not download the app, but you're doing it online. So that's software as a service. There is another one which we call PaaS, PaaS, which is platform as a service. So this allows you as a developer or a person to be able to create certain applications. So this is able to allow you to create certain applications. Like for example, when you look at the Google App Engine, so this is able to allow you as a developer to create applications. Like for example, when you create a small, let's say, game, you are able to create a game through the platform as a service. They are providing a platform for you. Then that's the main difference. So for such a thing such as the software as a service, you will have to pay something. So software as a service, they don't allow you to download, but you can do it online. You are doing Excel online, documents online. 66 RAM is remember, RAM is volatile. ROM is non-volatile. It is permanent. So this is not rewritable because it stores certain information that is important. So remember the one that I am constantly giving an example, which is the BIOS, which is the basic input output system. So it allows the computer to know how to turn on. So that type of information should not be able to be rewritten. It should be fixed. The computer should always know how to turn itself on. Then cache memory is used to, so it is mainly used to speed processes. Like for example, if you look at where we have something like this could be cache memory. Then we have something like this. We have something like this. Okay, let me not show it there. Let's say we have something like this. This is a RAM. So the smaller one is cache. Then here we have the CPU, just as we said. So it is the cache is going to improve access time by reducing the amount of time needed for frequently accessed apps. So it speeds up the processing. Then number 7 means if you are saving something, it means to say you are moving data to storage. That's the meaning of you saving it. It means to say you are moving it to storage. You want it to be permanent like that. So that is what we call saving. Our 70 address refers to address, which is address. We know what address is. It is just the location. Now in this case, it is the location of a byte. Where is that space? So a byte is a unit of space. Where is it located? That's address. 71 byte is, so it is a storage unit. So our 71, it is a storage unit. It is used to hold space. Then when we look at our 72, we have ROM stores startup instructions. How the computer is going to start up. ROM stores that through the use of the basic input-output system. I'm repeating this so that you don't forget. Then when we look at our 73, firmware is stored in. Now that same BIOS is an example of firmware, which is stored in ROM. Then when we look at our 74, flash memory is used in. So I've already talked about the flash memory. It is used in SSD, which is not made of moving parts. This RAM flash memory is secondary storage. So when we look at our RAM, that's primary and all that. Then when we look at our CMOS, which is the complementary metal oxide semiconductor. So we have the complementary metal oxide, then S we have semiconductor. So complementary metal oxide semiconductor uses what we call a battery. So now why is this important? CMOS is important as it works hand in hand with the BIOS. So remember the BIOS, basic input output system, it shows, or rather determines how the computer starts up. It is permanent. But the CMOS, like for example, you will find that, let's say if a phone is off, you will find that when it's turned on, it will be, let's say it was off at 11 hours. When it is turned on, the time will be 13 hours. So that is the working of CMOS, which is the complementary metal oxide semiconductor. So there is a backup battery that is able to sustain the device though it is off, to maintain certain things such as, let's say if you are to turn on the device, which device is supposed to turn on first. That is all stored in the CMOS. And also just the maintenance of time and date is an application of CMOS. Then when we look at our RAID improves what we call reliability. RAID simply means to say we have redundant array of independent disks. So we have redundant array of independent disk. So this promotes reliability. So I'll tackle the questions together when I explain. The RAID level 1 is used in mirroring. I'll explain this. Is there any other one? Okay, so that's the only two. So let me explain them now. So this is RAID 1, which promotes mirroring. So what it does is that information is stored into the exact. That's why it's called mirroring. So we have A, then we have the backup of A, so that in case there is a fault in A, it will promote redundancy, which means to say no fault in terms of the storage of memory. The exact things that you lost here, you will find them in a backup. So that's the redundant array of independent disks. So that is RAID level 1. The others promotes what we call stripping. So the other levels just promote stripping, which simply means to say the data is more like distributed to increase access type, like that. So when data is split into more like smaller cabinets, that simply means to say it can easily be able to be accessed. Because for example, if you put something here, you put something here, you will know exactly where to go. So if it is here, you will first get that thing. If the other thing you want is here, you will simply get that. Unlike if there is only one space and you will have to constantly look for things. So that is how RAID works. So this one, these other levels. Level 1, mirroring. These other levels will mostly promote what we call stripping, which is a way of splitting data into more like different disks like that. So we have the network attached storage, so which is the NAS. So this is where we have the network which you can access on the internet. It is stored in a central place. Like let's say you have these devices, then these devices, if they want information, they are getting it from this. So it is stored in a central place. In another unit, which is in unit 6, I explained this further. So these are able to access this information like that remotely anywhere in any place. Then when we look at our SaaS, which is our SAN, this stands for, so SAN simply stands for, where are we, 79? SAN simply stands for storage area network. So this one just essentially connects our servers, which I showed you, our servers with a centralized storage device. So another device that holds a lot of data is connected to a server. So that is how SAN works, which is the storage area network. So what this does is that it provides more high-speed storage network, so you can easily be able to access this information at a very quick rate. Our AET is RFID, uses ARA, which is the radio frequency identification. This one uses radio waves. In unit 6, I explained this further. Thank you very much for watching. If you are new, kindly like, subscribe, and share for more. See you in the next tutorial.